So here's the first one. Find the cross product, and then they're going to ask you to sketch your result. So here is I have the component J and the component I. That means you're going to do, so question one, you're going to do the cross product between I and J. But first of all, J, they're telling you J cross I. So J equal, it is 0, 1, 0. This is the standard unit vector. And for the I is 1, 0, 0. So if you want to do the cross product, that means J cross I is going to be 0, 1, 0, 1, 0, 0. This is positive, this is negative, this is positive. So the result is going to be, for the I, 1 times 0 is going to be 0, minus 0 times 0, 0. This is for the I. Minus, for the J, here's for the J, is going to be 0, minus 0. This is the J. A plus, for the K, is going to be 0, minus 1. This is for the K. This is 0, this is 0. That means the left, the result is going to be negative K. So the result for the cross product between J and I is going to be negative K. That means when you sketch it, check here. It's a negative K. Look here, we have I, and here is J, and K here. K with the Z coordinate. But negative K is going to be with the negative Z. Check this graph, I, J, K. They're telling you this is the right answer. They're telling you positive K, the right answer. They're telling you, no, J is the right answer. No, it's a negative K. So it's going to be goes down to the negative Z coordinate. This is X, this is Y, and negative C is going to be down. So I'm going to choose this one. And the result here is negative. Careful, here is negative, and K from here. Let's go to the next one. The same thing, but now we're going to multiply I times J. I times J. So always it's easier when you multiply, just write down a whole coordinate and do the cross product to find which one is going to be the result. So I times J is going to be also the K, but is going to be positive. Let's check that. So for the second one, we're going to multiply I times J. I, which is the vector 0, 1, 0, and J is going to be the vector 1, 0, 0. So I cross product with J is going to be, here is the I, and here is the J. Always negative here, so the result is going to be, for the I cross, yes. For the I, it's going to be 1 minus 0. This is the I. I have something wrong because this is J. So I is 1, 0, and J is 0, 1. 0, 1. So here's 1, 0, and here's 0, 1. Yes. So for the I, it's going to be 0 minus 0. Minus. For the J, 1 times 1 is going to be 1 minus 0. Go ahead.
The bottom one, isn't it 0, 1, 0 instead of 0, 1, 1?
Yeah. 0, 1, yes. So for the j is going to be 0 minus 0. Here is the j. Plus for the k is going to be 1 minus 0. So the result is going to be positive k. That's mean for this one, the result is just k. And the graph is going to be positive k with the z coordinate is going to be this one. Let's keep going. Same thing, you're going to multiply j with the k. J is going to be 0, 1, 0, and k is going to be 0, 0, 1. Do the cross product is going to be, I think, is going to be I, but I'm not sure it's going to be negative I or positive I. That's going to be the same process. K times j. You're going to do exactly the same thing. Example 5. Now we have two vectors. We need to find u time cross product between u and v, the cross product between v and u, and the cross product between v and v. What's the result for the third one? The result for the third
0.
one is supposed to be 0. Because any cross product between the vector and itself, 100% is going to be 0. Let's check what's the cross product between u and v. So for the question 5, our u vector is 3. I'm going to write down as a 3 and 8. 0 for the j and 8 for the k. And v is going to be 4, 8, negative 6. 4, 8, negative 6. So the cross product between u and v is going to be equal 3, 0, 8, and 4, 8, negative 6. Always positive, negative, positive. This one's going to be for the I 0 minus 64. This is for the I. Plus or minus for the j is going to be negative 18. Negative 18 minus 32. Plus for the k is going to be 24 minus 0. Do you have a problem with these? You want to do the steps again? So now 0 minus 64 is going to be negative 64i. Don't forget, there's a minus here. Negative 18 minus 32 is going to be negative 50. Negative 50 times this negative sign is going to be plus 50j plus 24k. That's u times v. So let's write down. I think we have to write down the result exactly like with the I and j and k. So it's going to be negative 64 with the I plus plus 50 with the j and plus 24 with the k. Now remember there is a theorem. It says u cross product with v is supposed to be negative v cross product with u. Let's check that. So if I find the cross product now between V cross U is supposed to be the same one, but different sign, positive 64, negative 50, and negative 24. Let's check that. So U equal 308 and V equal 4, 8, and negative 6. Now let's find the cross product between V and U is going to be V, that's mean 4, 8, negative 6, 3, 0, and 8. So this one is going to be, for the I, this is negative, don't forget that. For the I, it's going to be negative 8. For the I is going to be 8 times 8, is going to be 64. Minus 0. This is for the I. Minus, for the J, is going to be 32. 32, this is negative 6. So 32 minus negative 18. This is for the J. For the K plus, the K is going to be 0 minus 24. So the result is going to be 64I. There is negative sign. 32 plus 18 is going to be 50. Then it's going to be negative 50. Plus or minus, because minus 24K. You see, this is also a proof that U cross product between U and V is equal negative a cross product between V and U. So we got the result here. 64I minus 50J minus 24K. Yes. And the vector cross product between the vector and itself always going to be 0. You're going to do exactly the same thing here, but the difference between this one is the form. This is the component form. Find U cross V. Now, determine if U cross V is orthogonal to both U and V. That means we need to find the dot product. Let's do this example. So the first thing, I'm going to find the cross product between U and V. U equal 4, negative 1, and 0. And V equal negative 8, 5, and 0. The cross product between U and V is going to be, this is U, which is 4, negative 1, and 0, and the V is negative 8, 5, and 0. We have 2 zeros here. Yeah, for the I, and here's negative sign here, don't forget that, is going to be 0 minus 0. It's for the I, 0 minus 0. Minus, for the J, it's going to be 0 minus 0. Plus, for the K, is going to be 20 minus 8. Because negative times negative is going to be positive. So negative 8K. That means it's going to be 12K. Here's the cross product between these two vectors. Okay. So I'm going to write down 12K. Then the next one, we need to prove that if you do the dot product between U and 12K, which is the cross product, the result is supposed to be 0. Let's check that. Let's do the dot product now. Between U dot product with the U cross product with the V. That means it's going to be 12K dot product with U, which is U is 4, -1, and 0. Be careful here. For the 12K, it's a 0, 0, 12 as a vector. And here is 4, -1, 0. So the dot product is going to be 0, 0, and 0. So it's going to be 0 times 4 plus 0 times -1 plus 12 times 0, and the result is going to be 0. So this is just another proof. The same thing if you say V dot product with U cross V, the result is going to be, now we're going to multiply V. V is -8, 5, and 0. We're going to multiply with the cross product, which is 0, 0, 12. So the result is going to be -0 plus 5 times 0 is going to be also 0, plus 0 times 12 is going to be 0. So the result is 0. That means the cross product is orthogonal to U and V. So the result here is 0. And the result here is 0. The cross product is orthogonal to both U and V. That's the solution for this example. So this one is exactly the same way to solve it. And if you look to this example, find the area for the program. That's it. When you see this one, just find the cross product between U and V. Then after that, you have to find the length for the cross product, because you need to find an area that means it's a number. Let's check that. How are we going to solve it? So, question 8. We have U equal 7, 6, -1. 7, 6, and -1. And we have the V vector equal 1, 6, 7. So the cross product between U and V is going to be 7, 6, -1, 1, 6, 7. This is minus always, so this one is going to be, for the I, is going to be 42 plus 6. I minus for the J, because -1 times 6 is -6, but there is minus between these two terms, so it's going to be plus. Minus for the J is going to be 49 plus 1. Plus for the K is going to be 42 minus 6 for the K. So this one is going to be 48 I minus 50j plus 42 is going to be 36. Okay. So this is the cross product between these two vectors. Now let's find the length of U cross V. It's supposed to be the area. It's going to be, how are we going to find the length? Square root of the first component square plus the second component square plus the third component square. How much is going to be the area? Let's check that. So it's going to be 48 square plus negative 50 square plus 36 square. This one is going to be 6,100. Take the square root for this number is going to be 78. Well, we can't write down this as a decimal number. So how are we going to find the square root of 6,100? Because we can't write down a decimal number.
Factor it.
How?
Factor it.
Okay, so yes, let's factor the 6,100. Which number? If we divide by 25, it's going to work. Can we find another number? 600. Let's divide by 625. No, you can't. So we can find the root by multiplying, because 100 times 61 is going to be 6. So it will be the square root, which is going to say this one is going to equal the square root of 6,100. Then we're going to say this is the square root of 100 times 61. And it's going to be square root from 100 is going to be 10 square root of 61. Because now 61 is a prime. So this is going to be the area for the parallelogram. Let's check that. 61, so it'll be 10 square root of 61. If you look to the next example, they can tell you we're going to use exactly the same process, but they're telling you here, find the area of a triangle with the given vertex. So now we have 3 points, and we need to find the area for the triangle. And they give you a hint. They're telling you, when you find the length of the cross product, the length for the cross product, just multiply the result by half. It's going to be the area for the triangle. But first of all, we have to find 2 vectors from these triangles, from these points. I have to find 2 vectors. So when we multiply these 2 vectors, it's going to be the area for the parallelogram. Divide by half, it's going to be the area for the triangle. So how are we going to find these 2 vectors? Let's check that. Let's assume that U, let's say U is the line between A and B, and V is between A and C. That means here is going to be A and B. Let's write down the point here on the side. A is 0, 0, and 0. B is 105. And C is -5, 2, and 0. So that's fine. Between A and B, so this is the terminal. 1 minus 0, so here's 1. 0 minus 0 is going to be 0. 5 minus 0 is going to be 5. This is the first vector. The second one, I'm going to say it's between A and C, A and C. So -5 minus 0 is going to be -5. 2 minus 0 is going to be 2, and 0. Now I have two vectors. Let's find the cross product. And then we're going to divide by half. Is going to be the area for the triangle. So the cross product between U and V is going to be U is 105 and V is -5, 2, and 0. This one is going to be, for the I, is going to be 0 minus 10. Minus, for the J, is going to be 0 plus 25. 0, 25 minus 25, and there is minus, so it will be plus. For the K, is going to be 1 minus 0. That means the result is going to be -10I minus 25J plus K. Then, next step, I need to find the length for this one, to find the area for the parallelogram. So the length for the cross product is going to be square root of -10 squared plus -25 squared plus 1 squared. That means 625 is going to be 725. 725, 726. Let's check that. Is that right? -10 squared plus -25 squared plus 1 squared, which is 1. So the result is going to be 726. Square root of 726. Now, what's the square root of 726? The second, this one, this number is going to be, also is going to be decimal number, and we can't use decimal number. So how are we going to find the square root for 726?
Can't we just plug it in like this?
Yeah, but I think they're gonna ask you to simplify it.
Oh, okay.
Yeah, because they're gonna ask you to simplify it, okay?
Okay.
Maybe they're gonna tell you wrong. Let's
Sir,
try. Yes.
I just went on with that problem. I was doing the tripper scalar product because there's 3 vectors. Is that wrong?
No, these are not vectors. Be careful.
Oh.
These are points.
The vertices. Oh, so I get
Yes.
it. So I can't use the triple scalar product.
No, because the triple scalar with vectors. Okay, next example, we need to find the volume. We have to use the triple scalar product. Okay.
Okay.
Yeah, because be careful. These are 3 points, so we can't use that. Okay, that's good. That's good. So you have, you can't use the triple scalar product with points. You have to find the vectors. That's why I found the first vector and the second vector. Because also I can't use the product with the cross product with the points. That's why I find the U and the V. Okay.
it. Yeah.
The square root of 726 is 11 square root of 6.
11 square root of 6. Yeah. 11 square root of 6. So now the last step, we're just going to divide this one by 2. That's mean half, which is the area of the triangle, is going to be 11 square root of 6 divided by 2. That's it. So this is the area that's tried. So first of all, this one is going to be 11 square root of 6 divided by 2. So if you look to the next example, yes, there is something wrong with the 11 square root of 2. Let's check that. It was 11 times 11 times 6, 726. Do we have something wrong with the? Let's try on here. The points 105, -5, 2 and 0. Okay, so I say A, B, so 1 minus 0, 0, 5. And AC, what, say it again?
Isn't 9 and 8 different because it's the area of the parallelogram and an area of a triangle? Wait a minute. Never mind, I'm thinking wrong.
On this one, when I did it for like our homework, I put the decimal in and it said it was right. So maybe try that. I don't know.
Oh, so you put a decimal? Let's try that.
Yeah. It
weird.
was a perfect square though, so I don't know.
So like you meant the square root of 726 and divided by 2. Let's try that. The square root of 726 and divide the result by 2. So let's try 13, but they didn't ask you to round it. Did they ask you to round the? No. Did you put the whole number?
Yeah, for my homework it was a different numbers. So it was a whole number.
13, 4. In fact, I didn't try to use decimal number. So I'm gonna try to use the whole numbers. 19, 19, 35, 35, 8, 5, 3. Let's see if we 5, 3. I don't know. Let's try it. No, still wrong. Let's see where's the wrong thing. So here's the mistakes. Here, this is for the k value is 2 minus 0, not 1. So 2 minus 0, that means here is going to be 2k. And then this one is going to be 2 squared That's me. How much is going to be? This is 100 plus 625. It's going to be 725. 725. So it's going to be 729. 7. Now this is a little bit harder. Are we 729? Is that which number? 729. How are we going to find the square root for 729? So let's try 729. Second function. 27. The square root for 729 is going to be 27. 27 times 27 is going to be 729. That means the area is going to be 27 divided by 2, which is same thing. So 27 divided by 2. Let's try that. Yes. The same thing with the example 10, but now you're going to use, and they're telling you, use the triple scalar product to find the volume. In this case, you see how many? These are vectors or points. You see, they are vectors. They are not points. So just gonna work on this one. Use the triple scalar product to find the volume. So we're just going to find use the scalar multiple product, which is, here is the first vector, here is the second one, and here is the third one. Let's start. Positive, negative, positive. There, we're going to start with the first one, the first number. 1, here's the 1. Then I'm going to hide this line. It's going to be 24, negative 24 minus 0. I'm not going to put I. Minus. The second number is a 3. Hide this one. So it's going to be 0 minus 24. So 0 is going to be plus 24. Plus 1. And hide this one. It's going to be 0 minus 3 plus 24. So this one is going to be negative 24. 3 times 24. Is that 72? 72. So it will be minus 72 plus 24. This one with this one is 0. So it will be negative 72. The length, the absolute value of negative 72 is going to be 72. Let's try this one. Did you find where's the mistakes?
I missed the positive sign on that last 24. That's where it was.
Oh, this one?
Yep. Yeah, I did that one wrong.
So you see where is the important thing? You have to be careful with the sign, okay? Because you know the process, but you're going to do mistakes. The last 2 examples, I think it's a 3 or 2. No, it's just a statement. They're telling you determine whether the statement is true or false if u not equals 0. And U times U, the cross product between U and V equal the cross product between U and W. Is that mean V equal W? Think about that. Line to find is the statement is true, is that is going to be V equal W. So let's multiply this one, and I think it's going to be V, U times V. U times V. Let's do the cross product. 1 0 0 0 1 0. So I is going to be 0. I minus J is going to be 0J. K plus K is going to be 1K. That means the result is going to be K. Then U cross W is going to be what? This is U 1 0 0 and W 0 0 1. For the I, it's going to be 0 minus. For the J, is going to be 1 because 1 minus 0, so it's going to be 1J. And for the K, K is going to be 0, 0K. So the result is going to be negative J. So is this statement is right?
No.
No. So the whole thing is going to be false.
Okay.
Sir, on
Yes.
that on number 10, I believe. What was it was 72?
Yes.
Well, wouldn't you find the triples?
Yeah, I did the triple scalar multiple.
Yeah.
See?
And then finding the volume would be finding the length of it, right?
Not the length, the absolute value.
The absolute value.
Yeah, because do you have volume in negative?
Yeah, volume should be negative.
Yeah, shouldn't be negative, so you have to take the absolute value, so they're going to be positive.
Absolute values.
Okay.
Well, wouldn't you use that like a squared plus b squared plus c
No,
squared to get
no,
rid of it?
no, not the length. The length only for the area. Okay.
Okay.
You're gonna find the length for the cross product is going to be the area. But for the triple scalar product, when you finish, even if it's going to be negative or positive, you have to take the absolute value, okay? Because the rule says, you go back to the notes, it says take the absolute value. You see, the volume is the absolute value, not the length, for the triple scalar product,
Oh,
okay?
okay.
And the area is the length, not the absolute value. The length of the cross product. Okay,
Got it.
there's the same thing, but I think with this example, this is just even a proof. Is the cross product between these two vectors is going to be 33? Just find the cross product. It's going to be true or false. Let's see the last one. The scalar product of U V W can be written as a determinant whose rows and are the components of these vectors. Is that true or false? When we did the scalar, triple scalar product, is the components, the determinant whose rows are components of these vectors. Is that right or no?
It's true.
It's true. This is the last one. So that's it. Wow, these examples.